It's important when faced with a set of parametric equations to be able to sketch the graph of those equations and end up with a plane curve. So in this example, we're asked to find the rectangular equation and sketch the graph. X equals t squared minus 2, y equals 5 minus 2t, where t ranges between negative 3 to 4. So what we typically do is we try to eliminate the parameter. So in this case, we can take this equation involving y and solve for t. So we have y minus 5 equals negative 2t. Divide both sides by negative 2. Y minus 5 is equal over negative 2 is equal to t. Then we can use that to substitute in for t in the other equation. Put that down here. So this tells us that x is equal to y minus 5 divided by negative 2 squared minus 2. Squaring the y minus 5 and the negative 2, we get x equals y minus 5 squared over 4 minus 2, which is the same as x equals 1/4 y minus 5 squared minus 2. This equation is now a rectangular equation. It's the equation of a parabola, which opens to the right, and has vertex equal to negative 2 and 5. So we could put our Cartesian coordinate plane right here. And now we can plot our graph. We know that the vertex is at negative 2, 5. For the purposes of this graph, let's go ahead and make each one of these marks equal to 2. So it's 2, 4, 6, 8, 10, and so on. And 2, 4, 6, 8, 10, and so on. So we know that our vertex is at negative 2, 5. So negative 2 and 2, 4, 5. Right here. We can find a couple of other points on the graph by, for instance, picking an x and finding the y's that correspond to it. So let's let x equal negative 1. Then negative 1 is equal to 1/4 y minus 5 squared minus 2. If we add 2 to both sides, we have 1 equals 1/4 y minus 5 squared. 4 is equal to y minus 5 squared, which means that plus or minus 2 is equal to y minus 5. Just apply the square root property there. Adding 5 to both sides gives us y is equal to 7, or y is equal to 3. So we get 2 more points on our graph, negative 1, 7, and negative 1, 3. This will help us to know how wide our parabola is. So negative 1, 7 and negative 1, 3. Let's put those on our graph. So there's 0, negative 1, 2, 4, 6, 7. Negative 1, 7. And negative 1, 3. So negative 1 and 2, 3. Remember, each one of our grid lines represents 2. Okay. So our parabola start to look like that. We may have to adjust it once we find some more points on the graph, but we can do that. Now, so our parabola is going to open to the right, and we need to eliminate the part of the parameter of the graph according to the restrictions where t is negative 3 to 4. So if t equals negative 3, then x is equal to negative 3 squared minus 2, which is 7, and y is equal to 5 minus 2 times negative 3, which is 11. If t is equal to 4, then x is equal to 4 squared minus 2, which is 14, and y is equal to 5 minus 2 times 4, which is negative 3. Alright, so we get 2 more points on our graph. We get the point 7, 11. So 2, 4, 6, 7, 2, 4, 6, 8, 10, 11. So my graph is off a little bit. Our point should be right there. Just fix that. This is the point 7, 11. And also the point 14, negative 3. So 2, 4, 6, 8, 10, 12, 14, 2, negative 3. Let's adjust our graph appropriately here. We know the graph has to go through those points that we just created, or just found out. So now our parabola should look like that. Like that. And actually, since our t ranges from negative 3 to 4, we know that our graph actually stops at that point 7, 11, and it stops at the point 14, negative 3. This is where the 7, 11 point is where t is equal to negative 3. And so the graph is going to sort of move or flow in the direction of the points 7, 11 towards the point 14, negative 3. So that gives us the orientation of the graph. Now we have a visual representation of the parametric equations x equals t squared minus 2, y equals 5 minus 2t, where t ranges from negative 3 to 4.